And welcome to my series of short videos in which we discuss how the Arduino interacts with various electronic components. Yes, in less than 15 minutes we'll go over the basics, how they can be used, hints, tips, tricks and traps. Now today we have a rather lonely Arduino Uno sitting here because today's video is all about code and how we can improve some of our coding techniques on the Arduino or indeed any other microcontroller. So let's jump into the first one today and see how your code stacks up. Yes, as I say, there's little to see on the workbench. I mean, that little Arduino will be doing all the stuff for us, the hard work, but we really want to look at the code behind the scenes. Now, I was going to do 2 or 3 of these sort of coding techniques in one go, but you know what it's like. What should be a 5-minute video with me turns out to be a half an hour. So let's just concentrate on one. Yeah, let's talk about range-based loops. You what? I want to give a big shout out to PCB Way, PCB Prototype, the easy way. Now we're all familiar with their special PCBs, $5 for 10 pieces, but you can also have flex PCBs, advanced PCBs, and of course you can order custom parts. Let's have a look at the CNC and 3D printing options they have. So it's 3D printing first. You upload your CAD files as you would do normally for a PCB, but then you select your materials and submit a quote request. CNC machining is pretty similar in the way you submit your files, upload your CAD files, select one of these many different types of material you can use, and of course there are also 27 different options for the surface finishing. Just look at a few of those there, from anodized, brushed, bead blast, spray painting, and there's more under that list as well. And finally, there's sheet metal, laser cutting and bending. So let's have a look at that. Once again, you upload your CAD files, select the product you want to make it from, and specify a few of the parameters here about whether you want threads, for example. And you can always submit your request for a quote, and it's about 7 to 9 business days to get it done. Okay, that's PCB Way. Excellent service, good quality. Why don't you check them out now? Okay, here we have a little noddy piece of code. I don't know if noddy translates well. It just means a very simple piece of code, something that a child would understand. Yeah. Now, just for completeness, for our friends over in American places, Noddy was a children's character, and if we search through eBay, searching for things like Noddy by Enid Blyton, you'll see there are loads and loads of books. And there's a picture, for example, of Noddy and his friend Big Ears. Just so you know now, so the phrase has come to mean if something's noddy, it means simple enough for a child to understand. Okay, hope that makes it clear. So we are using libprintf again because it just makes the output easier on one line. Printf is wonderful for the ESP32, and this library brings it into the Arduino as well. Yes, we had that video there that I keep plugging away because I want you guys to use it because it really does make a huge difference to the readability of your code, and you'll just find it so easy. Anyway, that's enough of that. Let's move on. Now, today we're looking at arrays and how we iterate through an array. So here we have an array set up with all these names of cars, brands of cars, I should say. I haven't specified how many there are because C++, will work out how many there are in these squiggly brackets, but you may have an array with a defined bound, so you might have 10 or 20 or 100 or a million or whatever, fine. Now, if you wanted to iterate through this array, and what we're doing here, of course, is just printing them out. But I suspect that in the real world, you'll be doing a lot more than that. You might code it like this. And it's a for next loop. So you say for count equals 0. So we will start at the 0th element up here. Count less than, well, the number of elements less than 5 because we start with 0. So there are, in fact, 5 actual elements. But because we start with 0, 0, 1, 2, 3, 4. Fine, okay. And we just increment the index of that for next loop. Yes, great. And all we're doing here is using printf to output that value as a string. %s, it's a string, okay? And the value we're outputting is the cars element of the counter. Great, okay, nothing fancy about this at all. We've already done this 1,000 times, 100,000 times. Let's just have a look what this produces then on the output. Let me bring in the CoolTerm window. Right, cool term window there. So what I'll do is disconnect and reconnect, and that will reboot the Arduino on my desktop, and it should produce some output in a second or two. There it goes. Hooray. Great. So we've output the individual values, and it's just basically gone through this array and printed them out one by one. Yeah. Now, of course, within this loop here, once you've got this particular element, the nth element, you can do what you like with it. You can update it, change it, whatever. Yeah, fine. We know all this. This is just groundwork. But is there a better way to do this? Make the compiler do a bit more work rather than you have to work out what to do in this loop. Right, I've just added a few lines of extra code in here, basically this loop here, and you can see that the construct of it is quite different because we're asking the compiler to do all the work. What we're saying is, here's the loop, right? So it says for auto, which we also used up here, which means we don't have to specify whether it's an integer, short integer, whatever. It works it out for itself. Usually it puts in an integer in there. I'll have to tell you that, but you know. Okay, so for auto, here's the name that I'm going to use for my individual element of that array, this one up here, in cars, cars being the name of the element up there, right? So we go, great. For auto car in cars, print it out. Now this means, of course, that the compiler has had to go away and figure out what you mean by cars, and it says, oh yes, you've got X elements up here, and you want to put each one of those in turn in a loop into this variable called car. Yeah, I can do that. It says I'm a smart compiler. I'll be able to work that out. And then you can just reference car as we did cars count up here. We can reference car and say print it out. Okay, let's see how that looks on the output then. I just put this extra dividing line here because it'll run this bit first, of course, and then this. And we're expecting, well, the same output, aren't we? Okay, let's. I've uploaded it, as you can see in the output window there. It's all done the compilation, so I'm going to connect, and it should print that loop twice. Here we are. So that was the standard loop from at the top here, and this one, range-based, and it's done it again. Cool. Now that's a nice, easy way of accessing all the elements in an array. You don't have to know how many are in there. So if, for example, we'd made a mistake and we go, oh, there's only 6 in there, and we'd actually put 6 there, that would have blown up. Or if it hadn't blown up, you would have got some very odd results, because obviously it's accessing an element that doesn't exist, which means it's trying to access some random bit of memory. Yeah. Now this way, though, we're saying to the compiler, you go and work out how many elements there are and stuff each one into this element here. Great, that's fine. Yeah, nice and easy. What can't we do though? Well, this arrangement here where we're saying car in cars, we cannot update any of the elements in here. It's a read-only element. So what does that mean? Now, what this means is, as this bit of code will show you, even though you can update this sort of internal variable here to anything you like, and I've just put Hyundai, is that how you spell it? I think so. We'd expect at the end of this loop here that each one of those elements in this array would say Hyundai, Hyundai, Hyundai all the way through, because we're updating each one. And just to prove the point, we're going to print out that entire array again. So let's upload this and see what happens on the output. Okay, it's uploaded, compiled and all that, uploaded, and if we press connect, it's going to reboot the Arduino on my desk. So let's do that, and we should see 3 lists. So that's the first one, that's the second one. Hang on a minute though, this one here, this range here, I was expecting to see Hyundai in each of these ones here. Now this shows that this element over here in the array cannot be updated like this, because that is a pass by value reference. When the compiler works what that means and saying, great, I've got an array called cars, and we've been through all this up here, yeah, and you want to put each one of those elements into this variable called car, which you've asked me to be an auto variable, so I'll work out which one it is. You can update it like that locally, but you're not updating the actual underlying array up here. Yeah, now if you've been paying attention to my previous videos about passing by value and passing by reference, you will understand what the answer is to this. Okay, so what we've done then as part of this range-based loop now is to say for auto ampersand car. Now the ampersand says pass me the reference of the underlying value into this whole placeholder, if you like, from this element of cars. It's the ampersand that changes things entirely from a pass-by value to a pass-by reference. So then we print out the value and change each one of the cars into a Mercedes. Okay, great. So when we then print them out again, simply here, without using a by reference, it's a by value, we should see every single one of them being a Mercedes, because it's overwritten here the actual underlying value within the array. And this is a great way of protecting the values in your array so you don't accidentally update them, but also a great way of updating something in your array if you want to. So just look at the difference between the syntax of that line, and the only difference is that the automatic variable that we've declared here called car, and that could be anything, fish, Ralph, whatever, it's just a variable name. This one is an ampersand passed by reference. This one is without the ampersand, so it's passed by value. Great, let's run this then. I'll connect this up and it should give us the results we expect. There we are. So the first time round here, it's printing out each one of these in turn, but updating the value to a Mercedes. So the second time we run it here, it's printed Mercedes every single time. Great, that sounds pretty good, doesn't it? So, range-based variables. It's available in our compiler, obviously, because I'm doing it here. So C++11 compiler does this. There are a few caveats, though. You cannot, for example, go backwards down the loop. You can't go from here, cries, let's say, backwards down the loop like that. Not in C++11. That's available at a much later release. And if you do want to go backwards down the loop, you're back to the original way of doing it with the for, count, plus, etc. The longhand way, let's call it. What else can't you do? I think that's probably about it, actually. There's some esoteric limitations, I'm sure, somewhere behind the scenes, but I've not discovered any further ones. So this auto-ranging method, whether it's this way where you protect the array from any kind of inadvertent changing, to this one where you're almost saying, because this is passed by reference, I'm going to change it, so make it so. Yeah, it's a great way of iterating through your arrays, is it not? Cool. Okay, well, there's a little tip for you. Now, I was going to make this much longer, but the next tip I got for you requires a little bit of juggling about, and it's going to be far longer than what we've got time for today. So stay tuned for the next one, and I hope that you do go and download this or just type it in yourself and just play about with it, because once you get used to doing it this way, you think, why didn't I do it this way forever? This is just so much easier. And it is great. Now, if you found this moderately interesting, entertaining, or something else, do please give it a thumbs up. Put your questions and comments down there, because YouTube like people to give comments and have a little bit of repartee with the video creator. That's me, by the way. And I'll see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.